Hello, we are here to present our Embedded System Courses project for this winter semester. First of all, let me start by presenting my team members. We have Ahmed, Tarek, Mansour, Menna, Nader, Elsayed, Claudine, Hani, Yehia, and me, Fady, Gamil, Isaac. Our project is called Baymax. So Baymax is an Arduino project aiming mainly for helping the elders and those having some chronic diseases to measure their pulse rate and temperature without going outside. So Baymax is user-friendly and it allows the user to check whether they are in the appropriate levels of temperature and pulse or not, thus maintaining their health and stay always on the safe side. Baymax consists mainly of an Arduino Uno board, a weather temperature sensor, a pulse sensor, a breadboard, an LCD, and 3 LEDs, red, yellow, and green. In fact, the weather temperature sensor should have been replaced by a body temperature sensor, but we couldn't get a body temperature sensor due to its unavailability in the market. So this weather temperature sensor is temporary and it shall be replaced soon by the body temperature sensor once it's available back again in the market. So this project is somehow not accurate. And now, as we finished our introduction, let's get you into more depth and details about our project, and let's start by my friend Ahmed, Tarek, Mansour, who will get you into more description about the pulse sensor and how did we implement it in our project. Thank you.
Okay, so moving on to explaining how the pulse sensor should work. First of all, we have LED, green LED, which light in our fingertip, and then this light bounces back to the sensor, and that signal is sent through the gray wire, which is the data wire. So the green LED of the pulse sensor is used to generate a green light to our fingertip, and then that light bounces back and is sent through the gray wire, which is the data wire of the sensor. So using time interrupt, we take a reading every 2 milliseconds. We discard the first reading because it's not accurate. And then starting from the second reading, we take 10 consecutive readings and calculate their average. And then, to get the beats per minute, we divide the time, which is a minute, by the average we have just calculated. And then that beat per minute is shown on the LCD. If the beats per minute is less than 120 and more than 60, so the person is safe and the green light is on by sending a high voltage signal and a low voltage signal to the red LED, and otherwise the LED is lit up and the green one is off. And moving on, Claudine will explain how the temperature sensor is working.
The temperature sensor is exactly what it sounds like. It is used to measure ambient temperature. This sensor has 3 pins, and they include the positive, which is connected to the Arduino's 5V, the ground, and the signal pin. It is a linear temperature sensor. A change in temperature of 1 degree centigrade is equal to a change of 10 millivolts at the sensor output. What our code does is that it takes the result from the volt and divides it by 1024, giving us the result in millivolts, which we will then multiply by 50 in order to get the temperature in degrees Celsius. When we get the temperature in degrees Celsius, it is then showed on the LCD screen. What happens is that if the temperature is below 36 degrees Celsius or above 38 degrees Celsius, the yellow LED starts lighting up, which indicates that the temperature is higher than the normal body. The case with our temperature sensor is that it is not the body temperature because, as said previously, we did not find the body temperature. This sensor measures the weather temperature. The LCD has 16 characters by 2 lines. In order to use it, we use backlight so we can see the output on the LCD. Later on, Menna will be explaining how the LCD is connected to our whole circuit. Thank you.
Hello. As my teammate Claudine previously mentioned, the LCD we're using is a 2-line 16-bit LCD that has a register select pin to control where in the LCD's memory we're writing the data, Also a red read or write pin that selects reading or writing from this LCD, an enable pin to enable accessing the registers, which are 8 data pins for writing the data, and this LCD also has a display contrast mode and an LED backlight. As you can see, our project didn't really need an external power supply. It only needed the 5 volts from the Arduino to be connected to a breadboard and then fed back to all the sensors and the LEDs. Our LCD also is attached to the breadboard, not the Arduino, so we don't jam. And that's it for our Baymax project. Thank you, everyone.